Alright guys, so we're going to just walk through some past papers for theory, looking at section B and D. But yeah, mainly scanning through them. So first one they ask here, explain the concept of open source in the context of FOSS. So personally, I don't like FOSS because FOSS is for free open source software. That's what FOSS stands for. But I mean, open source software is free. So they just want to know, what does open source mean? Do any of you know? Yes, so so your keyword here is actually, it's not copyrighted. So that's sort of the word that sort of does everything. Um, this one is 2 marks, so I think the copyright part should be 1. Then over and above the copyright is, you can see the source code, you can change the source code, and you can do all those things because it's not copyrighted. And that's sort of the key factor of that. Give one example of a free operating system that a company could install on a laptop. That would be, yes, Linux. Perfect. Okay, state 2 disadvantages of free open source software. What do you guys think? What is the disadvantages of it? Maybe I actually think that improved nowadays. I actually think you will get automatic updates as well. But the main thing is, because it's free, there's not like a base of people that can actually help you and assist you. So generally, like, yeah, assistance is difficult to get. Yes, yeah. Yes, you can. So the whole idea of open source, why it's good in any case, is there's a lot of good programmers that sees the benefit of it. So it's like community based type of thing. So generally, you do have good updates and stuff, but you don't have people employed to like a call center where there's somebody that could answer and help you to go through things. And generally, if you find an error or something, you can post it and hope somebody fixes it for you. So it's not like Windows also, where you'll get regular updates and there's actually people constantly checking and improving. So yes, you can say the way you phrased it, because they're not there. But yeah, technically you will still get some updates and stuff. But yeah, you can't depend on it. Um, yeah, anything, because there's no money involved, then they don't have full-time staff and anything basically based on that. Defragmentation. Users equipped defrag HDD regularly. Explain what defragmentation is. So what is that? Yeah, so defragmentation is the program or the process of, yes, reorganizing the files on the hardest drive, and the fragmentation occurred because of the adding and removing of files throughout the years. Yeah, so that should be fine. Abbreviation SSD in full. Yes. With all these things, generally look at the mark allocation as well. So make sure you mention 2 things at that one and 2 things at that one, like 2 facts, to make sure that you sort of get the 2 marks. Okay, then I want to know, explain why SSD accesses the data faster than HDD. So again, it's 2 marks. So what would you say? Yeah, so personally, I don't like the word electrical. Change it to electronic. Because the thing is, a hard disk drive is also electrical actually, because it also needs electricity to do what it's doing. but a hard disk drive is mechanical, while a solid SSD is electronic. Yes. Ask me. What about signal? What do you want to mention? Why would the SSD travel faster? No, no, no. So SSD, you're confusing now fiber optic cables and UTP networking stuff. So yes, SSD is also SSD and hard disk drive is basically the same thing. The difference is a hard disk drive. If you open it up, there's a lot of moving parts. It's mechanical. There's a disk that spins. There's a read-write arm that moves up and down, and that basically reads the information. While an SSD, if you open it up, it's just like a circuit board. It looks like a memory stick. Those of you that opened up a memory stick, it literally just looks like that. So that's basically the main difference. So with this one, for the 2 marks, you'll say SSD is electronic, while a HDD is mechanical. So you'll say the SSD is much faster because it doesn't have any moving parts. And that would be your second mark. Um, but the type of signal is exactly the same. Both use basically electricity with copper wires to send it. You'll see the cable that connects your SSD and all those things is still copper, so they literally send electrical signals throughout. So it's not optic. Yeah. Yeah, and I will say electronic. Yeah, electronic and no moving parts. These are like the two elements that would get you 2 marks. All right. No, because it's 2 marks. Once it's 2 marks, you must know you must say two things. So, but the only reason why a SSD is faster is because it's electronic and HDD is moving parts. But then when you start expanding it a bit for your second mark, if you just say because the HDD has got the moving parts, it takes longer to go read information. Um, s- that is actually it's similar points, but they are actually separate. Because it's mechanical, it makes it slow, and then because it's mechanical, that means it takes longer to get to the place where the information is stored. While with a solid state, it's not. So you'll have to, for 2 marks, definitely say mechanical and add the moving parts part. You'll have to have both for the 2 marks. All right, then virtualization. What do you think? What is that? So they're talking here about comparing virtualization versus software as a service. See, there's a SaaS. So that's what, yeah, I just don't know the P thing, but yeah, yes. Do you know what you just said now? Do you understand what you said? Does it make sense to you? All right. Yeah. It's it's closer to a virtual machine, but it's also a very the explanation is very dodgy. All right, so somebody else that wants to try this for us. Yeah. Well, in this case, you don't need to. You can. Um, so so for a virtual machine, that's perfect. Yes. A virtual machine is basically when you're running another, they call it a client operating system within a host operating system. That is virtual machine. Yes. The trick with this virtualization is you'll see it's not actually virtual machine, it's virtualization. And then they're comparing it to the software as a service. So what this virtualization, anything with virtual, sort of to summarize it for you, when you see the word virtual, it is software that makes the hardware look different. And I think that's what Mr. Walker should try to convey to you guys. And that's virtualized. When you hear or see the word virtual, is software that makes the hardware looks different. So what I mean with that is, if you go VR, virtual reality. So we're using software so that it looks like the reality is different. Um, Virtual memory. Guys, have you done virtual memory before? Virtual memory. Something like that, but yeah, not that. But yes, so it's when we use basically the hard drive to substitute some of the RAM. So we don't have enough RAM space. So then some things that needs to go to RAM we actually put on the hard drive, and that's virtual memory. So again, it's software that makes us that makes it look like we've got more RAM than we actually have. So that's where the whole virtual word comes in. So when you see the word virtual and you're not too sure, it doesn't matter in which context. Basically, if you go, it's software that makes the hardware or reality look different. That's a very good case, and you might actually get some marks even though you've got no idea what's happening, but you see the word virtual. That sort of covers everything. So what this one does, this virtualization, is let's say you go to, or I go to my OneDrive. If I go to OneDrive, do you agree? It looks like I'm on my own hard drive and I'm just working with my own stuff. And if you go to, let's say Office, if those of you that's got Office 365, I think all of you actually got it through school. But if you go to the online application, then you can have Word, Excel, and you can use those applications on the internet as if they're on your computer, as if you're using your own computer. And that's this virtualization. This virtualization is we're using um, online resources or resources from a server somewhere, and it seems like it's our own resources. And that's what they mean with this virtualization. So they're fooling us in with like I just said now, with our online office and with OneDrive and Google Drive and all those things. It looks like you're playing and working on your own computer, but you're actually working on a server somewhere. And even if you know that, it looks like you're using that server for yourself. But in reality, that server is actually being used by many different people for many different things. But it looks like it's just for you, like dedicated. That's your space. If you go to that OneDrive, you can only see your files, nobody else's files. And that's the virtualization part. So for this definition, define the term virtualization. You can say something like it is software that allows a online server to look like it's part of your own computer system. Something like that. Anything that sort of relates to software where you use online resources and it looks like it's your own and only you can use it type of thing. That's this virtualization. Everybody got it? All right. So now they went on, they say this Office 365 is an example of SaaS. What is SaaS? SaaS, they said, yeah, is software as a service. So you're lucky in this question they actually said it. A lot of times they want you to expand it actually. Then you'll have to say software as a service. But so who knows what is SaaS? Yes. All right. So for 2 marks, unfortunately, they already gave the example. So, but the one part that you did say is very good is it's a license you pay for. So SaaS, it's not a once off, you buy it and then you own it like a normal, the old office stuff. You continue every month, you have to pay your subscription, or you can get that yearly fee, but you don't just buy it once off. You have to pay the or rent it, like Pavan stated correctly. So that is one key concept to know that actually falls into the second part of the question. How does the license model work? So the license model is you can never own it. You pay the license either monthly or yearly, and you never own the software. You will need to continue on paying while you want to use the software. And once you stop paying, you'll stop having access to the software. So that's sort of how it works. It's similar to Netflix. Is also similar. And a better example for me is actually like accounting software. Those of you doing accounting, if you learned about or you know about like Pastel, that is while you're paying the license, you can use it, and they actually do nice bookkeeping for you. But as soon as you stop paying, then you don't get it. So now the A part of this, except for remote access, state two other benefits of SaaS. So what benefits do we have then of this software that we have to pay for forever, basically, that we never own it and it's a once-off thing? What is the benefits of that then? Yes, so that is one nice one because, like those of you that do have Office 365, every time they see something new, they will implement it, and because you pay, it's basically like you're buying it every month. So, and because you're buying it every month, if there's a newer update, you get the newer version. So that's the benefit of it. You will always have the latest version. You don't need to worry about updates and stuff. You will always get that. What else do you think is a benefit? Yeah, yeah. Yes. Yeah. So online service, if you don't want to use the word service, you can say online program or online software. Yeah. So the whole idea of this, why they went software as a service, is this software is starting to replace people's jobs. So this is like the Pastel accounting. Because now you can pay that, and if you just load your stuff, it's sort of like you've got your own bookkeeper that you're already paying for. And that's what they software as a service. So it's software replacing a normal service you would have had in the old days. Um, you also get like doctors programs where you can maybe pay a monthly fee or whatever, and then you can give them like I don't know what when you're sick and stuff, and they will give you like what medicine you should use. And there's different kinds of software that you can rent to give you certain services you would have had in the past. All right. So then we said one benefit, always up to date software. Other benefit? Yeah, the other one is with this software as a service, we're working on the internet. So they say except for remote data access, but other than the access, it also stores data. So we're storing data online. We do have remote access, but that we can't mention now. We do always have the update. We're using the processing power and resources of the servers we run it on. So your own device doesn't need to have that strong a computer. I mean, this Office 365, if you run it from your phone or from your laptop or from your desktop, it doesn't matter. You can run it from anywhere and it will work fine, or from any, I want to say, weak. So I'm not focusing on the remote access, I'm focusing on the part that your device doesn't matter. Because you run it online, all the processing gets done on the servers. So you don't need to continually upgrade your device to have it run efficiently. and stuff like that. So you can actually save on your own resources of your PC because you're using the resources of the company server. All right, everybody got sort of that idea. All right, hope so. Okay, then the company takes precautionary measures to protect the magazine's data. Incremental backup. Somebody got an idea what incremental backup is? So your alternative to incremental backup is a full backup. What a full backup will do is you'll back up all of the stuff on your computer. So everything, a full backup will go and back up everything that you've got on your computer. So if something happens, you can recover everything. Generally, after your first full backup, you can change over to an incremental backup. What that will do is that will just back up all the stuff that changed from the last time you did a backup. So only the new files or only the files that where there went something changed, only those ones would be backed up, not everything again. So that's the nice thing of incremental one. So you only back up the stuff or the files that changed from the previous time you backed up. And then that saves space. Yes. Yes. So you have to start with a full backup, and from then on, incremental is everything that changes from or changed from the previous time it was backed up. So if you needed to compare the two, what would be the advantages or disadvantages of either way around? What would be the advantages of incremental and what would be the advantages of just doing a full backup every time? Both has got advantages. But so what would that be, do you think? Second winner? All right, so yeah, but I think I need to clarify some things. Um, so first thing, remember with a backup, can I just, somebody needs to mute for me. All right. So remember with backup, what backup does is it basically copies your work for in case something happens. So if I make a backup of my computer now, there's okay, so this is different strategies of how to backup, but you get different locations as well. You get a local backup and a cloud backup. So when you do cloud backup, it means I can do a full cloud backup. That means it will make a copy of everything on my hard drive and copy all of that to our online storage. And I can get a full local backup where you plug in like a external hard drive and you copy everything on your computer to that hard drive. And then you've got a full version of everything that's on your computer is also on the external hard drive or on the internet. But same as that, you can get the incremental one. So if you do a online incremental, means you'll have one folder, which is let's say on the 1st of January, you do a full online backup and you create a folder called 1 January and it copies everything to there. And then maybe you do a setting on your computer or you schedule so that every 1st of the month it makes an incremental backup. So what that will do is 1st of February then it would create a folder for 1st of Feb, and all the files that changed, it would back up to that folder. And then 1st of March, it will create a folder, and everything that changed from 1st of Feb, it will make a copy there. So now, if you look at that online storage, you'll have one folder with the whole of January, with everything there, and then you'll have a much smaller January and February and March folders with only the few documents that changed will be in there. Yeah. Yes, it will be like WhatsApp then. Yeah. So the the downside of the benefit of the full backup is once you lose your computer, you can just go to that 1st of March folder, for argument's sake, or 1st of Feb folder, and you can just copy everything back, and then everything is sorted. And then, so the recovery is, I want to say, faster. If with the incremental one, something happens to your device, you'll have to start with the 1st of Jan one, and then still do the Feb one, and then do the March one, because you have to copy all the changes as well. So you've got more folders to go back to change your um, or to get back to the latest version of what you had. Yes, it depends. If you depends on what you did. Um, so if you lose your device, you will need to start at the back and then move your way through. But what happens sometimes is you just want to roll back. Sometimes on your computer, you could install some dodgy software, and then you just want to say, I don't want to start over, but just take me back to where I was last month this time. And you can roll back. So that's why incremental helps you, because then you can just, how to say, undo the stuff that happened in the past and you go back to that point. While with a full one, you have to redo everything, sort of, basically. Um, so the disadvantage of a full one is it uses a lot of data every time. Every month you have to back up everything. So it uses a lot of data, a lot of time to do it, because every beginning of the month you have to copy all of your work to a certain server. So that takes a long time. While with the incremental one, it's much faster because you just look at the changes. So that's a downside of a full one. It's everything every month, while the incremental is only the changes, so it's much faster. But when you get to recovery time, then incremental is worse off, because then full is easier. You can just take the one and you're back where you were. While the incremental one, you have to start when last the full one was done, and then work your way through all the other versions to get to the latest version. I don't know if if I explained that nicely now. Recovery time is like when you lose your laptop, when you throw your laptop out of the window, or when it gets relocated to somebody else's house and stuff like that. Yes, so now so your laptop gets stolen and you're very sad. Insurance pays out and you're very happy. Then you buy a new laptop, then you're very sad again. But then when you get to your new laptop, you're very happy again. But then you see your new laptop is blank and all your stuff is gone. But then you remember, I've got backup. And that's where the recovery thing starts now. So if you had a full backup, you just copy all that down, you're back to where you were, you're very happy. If it was the incremental one you were using, you have to start at the original full and work your way through all the backups until you get to the last one to have the latest version of what you had. So with the incremental one, it actually takes a little bit longer to do recovery, while with a full one, it's faster for the recovery process, like when something happens to your data. But during the years, just doing the backups, incremental is much faster than a full. So you sort of have to think, what is the odds of you actually needing the recovery, and then weighed up as to how much time do you want to spend each month or each day or each night or whatever. Yes. Yeah. Yes, you can see it like updating the backup. Yes. All right. So that's all the backup stuff. Now they talk about biometric readers. What is that? Ka- Kampavan, tell us. Yes. Yes. So biometric is to your biology aspects of your life. Yes. And all of your person. So it's your fingerprint reader, your retinal eye scanner, um, any voice recognition, whatever, DNA scanning, I don't know, whatever. All those things are our biometric readers. Yeah. So, so that was how would it safeguard? So the nice thing about biometric is you don't need to remember the password and it's very unique. So and people can't steal it easily or replicate it easily. Yes. I would, however, just add the biology part. So what you said is perfect, but then so it forces the user to give authentication with his body, with his physical aspects or his physical characteristics. Something like that would be perfect. Yeah. Yeah. Perfect answer. Yes. Yeah. Very good answer. That. Yeah. Okay. Then let's look at the next one. Power outages and power surges often experience rural areas where journalists work. What device can be used to ensure journalists are not affected by unexpected power outages? So what can they do? Yes, perfect. So this question is very vague. Um, I think they phrased this question because they wanted UPS as an answer. But the way they phrased it, if you went generator, that's also acceptable because they just said would not be affected by unexpected power outages. So the thing, okay, so if you're not too sure, I'm quickly going to explain this. So a UPS, those of you that don't know, is uninterruptible power supply, and a UPS is basically a battery. Now, a UPS is not meant to last long. So if you've got a UPS, generally in computer systems and computer labs, your UPS lasts between like 5 minutes and 30 minutes. That's sort of the general norm for a UPS should give you about, let's say, 5 to 10 minutes of power and then it switches off. But it does help because a UPS can run constantly. So you'll plug the UPS into the wall and you'll plug your computer into the UPS. So as soon as the power goes off, the UPS would automatically kick in and give you power while the power is off. So your computer won't die. It will stay there so that you can quickly save your work and all that stuff. But that just lasts for a limited time. And that's why you'll see companies and schools and stuff, they've got UPSs and they've got generators. Because a generator, what's him good is he can run for hours and hours and give you power the whole time. But he can't run constantly while you're on ESCOM power. So as soon as the power goes off, everything would die. The generator would start up and then everything will come alive again. But then if you didn't save something, all that work's lost. So that's why generally companies use both. They've got UPSs, so that as soon as the power goes off, the UPS kicks in, and while the UPS is working, they start up the generators. And once the generator is up and running, then the UPS is shut down again. So the UPS takes over. So then you've got constant power the whole time. So, but this is just a journalist. So I think for him to have a generator is a bit tough. Um, so that's why I said I think they actually wanted to say UPS here, but a generator also leans itself towards helping them. So yeah. All right, everybody good? UPS generator. All right. If if the USB ports of a laptop are damaged due to a power surge, how could a user get his or her peripheral devices to connect to the laptop? So they can use a USB hub. I think that's the answer they wanted. Again, this question is just so dodgy for me because I mean, they said if the USB ports of the laptop are damaged. So that sort of tells me that none of them is working. Yes, talk to me. Bluetooth, I think, is the better answer. Because with this one, so I like the USB hub, but a USB hub needs to be plugged into a USB port. And they just said now, yes, yes, I, yeah, yes. What is a peripheral device? Let me just ask you that first. Yeah, but it's basically hardware. I want to say on the outside. So it's our keyboard, our mouse, our speakers, joystick. Yes, yeah, yeah. Alright. Yes, they want physical stuff. So here's a picture. You can't see it nicely, but this is a USB hub. So you'll see. Say again. Yes, I am. So it's a. So on this side, there's a USB that you can plug into your USB port, but then you get like four others on this side. So you can use this is a USB 3, so it's the faster one. So if I plug it into a USB 3 port, then I get four more that I can use in for all my other devices. Yeah, my problem is I've also on my laptop after I plugged in my keyboard and my mouse and my headphones, I don't have anything left. So now if I want to plug in a memory stick, I can't suddenly. So that's why I want to get that just so that I can at least use more of it while I'm busy. So yeah, because nowadays you actually use USBs for so many things. And one stupid thing from my school was I asked for a wireless mouse and keyboard, but they went and bought it separate. So now I've got one dongle for the keyboard and one dongle for the mouse, and then with my headset and my laptop only got three ports. So they all three ports are gone because of just those three things. So that's why I need the hub now. If you buy them together, generally you get like the one USB dongle that will cover both the keyboard and the mouse. That's just so much more efficient. But yeah, it is what it is. All right, so yes, yes. Yeah, I'm buying new mouses as well for ours. If you saw the yeah. Oh, that's a Red Dragon one. Or I actually want these ones. These ones. The Asus Tough. They just look good. So I'm thinking I'm getting these ones. I want to double it up for esport and for my class. All right. So yes, I agree with this one because I said if the USB ports of the laptop's damaged. So I think you have to assume all the ports are damaged. So they didn't say one. So I think Bluetooth is your best option to connect devices to it then. Right, then they're talking about who to classify these units as power users or SOHO users. SOHO is, what does that stand for? Okay, so that's small office, home office. So yeah, I hate it when they just give abbreviations, especially it's not even, I want to say it's not even a computer abbreviation. It's like literally the type of office, like I want to say this is a business abbreviation. And then if you didn't know, then I think this year this question slaughtered so many students just because they didn't know this stupid abbreviation. But yeah, small office, home office. So that's the people working from home. You know, just a normal. Well, it could be like a dentist even. Dentist working from his home, or doctor, or anybody starting their business, maybe a bakery or whatever, starting a business from home that they're doing. So, do you think a journalist, do they classify as this type of user or a power user? Do you know what a power user is? Let's go back there. In South Africa, we would think it's people that work at Eskom, but no. So these power users, that's basically people that needs powerful computers. So that would be your gamers, that would be your graphic designers, that would be your technical drawing, your EGD guys. It would be people working with either pictures or videos and doing all those like compressions. And so it could be anything from designing to yeah, making of videos or cutting of clips. And so any type of career where you need a powerful computer. And generally powerful computers has to do with something that has got a lot of graphics processing. And that's why EGD is very big maps, gaming very quick changes of images, and then graphic designers and then working with large images and working with a lot of images at the same time. So they are generally seen as power users. So where would you classify journalists? Do you think they need a very powerful computer or not so much? Not so much. I agree with that. A journalist generally uses like Word and the internet. So they'll be the small office, home office users. Then explain how multi-threading is applied in word processor. Okay. Yes. So I'm happy with that. So multi-threading is you taking one program, breaking it up into smaller pieces, and each of those pieces are run and processed individually. That is the two marks you're looking for. So the first part is for one program being broken up into smaller pieces. The second mark is for each of those pieces are run independently and processed independently. So um, this multi-threading, he's got friends. The multitasking, what does multitasking do? Yes. Okay, I'm happy with that. I think with both of them, try and always explain them with keeping in mind you've got one CPU. So let's say that was our CPU. Let me make this a bit bigger. Right, let's say we've got one CPU. So what multitasking does, it will allow you to do it up there. It will allow you to run, let's say, Word and let's just choose, I'm just going to use two examples. So let's say Word and Media Player. you're listening to music while you're working on Word. So that is the benefit of multitasking. So multitasking allows you to run two programs at the same time. You guys didn't see the big difference, but like when I grew up, literally if you went into Windows, it was Windows 3.1. If you opened up Word, that was it. It literally like Windows closed and that Word program opened up, and that's all you can use. There's nothing else. There's no minimizing, nothing. If you've got one program running, that is it, nothing else. So yeah, so you used it's at inverted quotes. So it didn't actually, but it sort of like went into background mode. You couldn't do anything with it. You couldn't minimize it or anything. You can't go back to Windows except if you close the program. So multitasking gives us more than one program running at the same time, but they are being processed individually. So what the CPU will do, it will give a little bit of processing time to Word, then a little bit to Media Player, then a little bit to Word, then a little bit to Media Player. The Media Player is a bad example. Let's say again, Fortnite. So what the CPU do, he would basically give 50% of his time to Word and 50% of his time to Fortnite. So those of you playing games know Fortnite needs a lot more processing than Word actually. But so what multitasking does, multitasking is nice because it actually allowed us to run both. So we're happy with that. But now what multi-threading does, is it allows Word, like Pavan said, to be broken up into a grammar check and a spell check. Let's do a spell check. So it breaks it up into two smaller pieces. While Fortnite can get broken up into, okay, let's go Fortnite different color. So Fortnite now can get broken into, let's say, the grass movement, and then the other players, and your man, so your own guys movement and stuff, maybe all the bullets, I don't know what else, clouds maybe, whatever. So it breaks up that one program into all these smaller pieces. So the benefit that we've got now, and they are all being run individually, like I just said, now they're being processed separate. So now we've got 2, 4, 6, 7 pieces here. So grammar check will get 1/7 of the time, spell check will get 1/7, then grass 1/7, that 1/7, that 1/7, that 1/7, that 1/7. So now if you think nicely about it, Fortnite actually gets 5/7 of the CPU's time, while whatever. You know what I'm trying to, this state thing's gonna change it now the whole time. Yes. Just change this to, okay, but you've got the idea. So this one is got 5/7 of the processing power, while this one will now only have 2/7. So by using multi-threading, we can prioritize some games that's got more threads running to give them more CPU time. All right, everybody good so far? You with me? All right, then they've got another friend. So both, okay, cool. Thanks, Lwande. Both of these two are software based. So the operating system does both of these two things. On the hard drive, not on the hard drive, on the hardware side, we've got multiprocessing. What multiprocessing does is this: we don't just need one CPU. You can get a quad-core CPU. So now suddenly we can have 4 CPUs maybe running everything. So now grammar check can go there, spell check can go there, grass will go to that one, the other players will go to the other one, and then these 3 will wait for the first one that's done. It will slot in and they'll rotate. But now everything can be shared between the 4 CPUs, and that is multiprocessing. So multiprocessing allowed us to have more than one CPU core to spread the load. But just remember, when you explain these two, try to refer to one CPU. Multitasking, having more than one program running at the same time, but being processed individually. And multi-threading, having one program broken up into smaller pieces, and each of those pieces gets processed and run individually. And that's threads. But then what multiprocessing does, it gives us multiple CPUs. Yes. Yes, a lot. Like literally 4 times faster if you've got a quad core. If you've got, I'm not exactly sure, but when you buy the CPU, they'll actually tell you. I think the latest, like i9s, is running like 12 cores, I think. So yeah, so but you won't know. So don't think because it's an i3, there's 3 processors. You literally have to read the model and stuff. Then it will say. I'm just looking for. Let's see. Let me see if I can get one spec that it would just quickly tell you. Um, yeah, well, this one. Okay, well, yes, 24 cores with up to 24 cores. So yeah, with 32 threads. Well, this is actually hyper-threading, this part. Um, yes, yes. So you'll see these performance cores, they've got hyper-threading on. So these 8 has got 16 threads, and then these 16 efficient cores, just other 16 cores with only one register each. That's how they got to the 32 threads. So your performance ones has got double registers basically, and the others not, and that's how you got to your 32 threads that can be processed at the same time. That's basically what it means. Yes, Dr. No, it's completely different. So these things we've got here, these things are threads. Each of these smaller pieces is threads. A register is part of the hardware. So a CPU is made up out of smaller pieces, and one of them is a register. So that's where there's a thing called hyper-threading. Hyper-threading. Yes. Each core will have their own set of registers. So there can be 2 registers, there can be 2, and there can be 2. So these things are registers, and a register, it's similar to RAM, if I can say it that way. Yeah, it's actually difficult. I just see time is running away with us. All right, so but yeah, let's do this nicely. So we've got there's 3 types of memory you get. Everybody's good between the difference between storage and memory. Storage is our hard drive, non-volatile. The power goes off, it's still there. But then, like RAM is memory. When the power goes off, information is lost. So RAM is your slowest type of memory. The faster after RAM, the one closer to the CPU is called cache memory. I don't know if you heard about cache memory. You get cache, the cache, like that. Cache memory. So what RAM does, RAM stores all the information the CPU, or it's trying to store all the programs that's currently running on the system. That's trying to be put into RAM. But as you can see here, these things are all running, but being processed is only some of them. So what cache memory does, cache memory stores the information the CPU will most likely need next. So cache is sort of guessing. What does he think the CPU will need next? But it will also have the stuff the CPU just processed. So it's sort of like the in and out. So the CPU is busy processing something, so the stuff it's done with, it sends to cache, and cache will send back the stuff that it thinks you will need next. And then the register is also, that's your fastest type of memory, and that's the one, I want to say it's part of the CPU. So everything the CPU is busy processing now is in the register. If you think about it logically, if you want to add two numbers, you agree you need to know both numbers, and that's sort of where a register comes in. If I asked you to add two numbers, but you cannot remember anything, I will ask you, please add the number 2. Then you'll say, okay, I remember 2. Then I'll say, add that to the number 5. Then you're going to tell me, okay, I know 5, but what must I add to 5? Then I'm going to say 2. And then you say, okay, I know I have to add something to 2, but what do I need to add to 2? Then I'm going to say 5. Then you're going to say, okay, 5, but what do I need to add to 5? Then I'm going to say 2. So do you agree? You needed to remember the 2 and the 5. If you can't remember anything, then you can't actually add them. And that's what the CPU does and what the register does for the CPU. So the register will allow him to remember the 2 and the 5 so that the CPU can actually add them together. So the register is memory where the CPU is busy processing with now. Cache is what it will most likely need next. And RAM is everything that's running currently. And that's sort of all three of them are memory, and they're just trying to speed up our CPU. Get it? All of you sort of get that. Hey, it's a lot. Sorry, I actually thought you told me you spend so much time on theory. I didn't know I needed to explain so many things. All right, sorry. Uh, oh, okay, that's good. Yeah, maybe if you want to share that just again for the rest also, or link. Oh, perfect. All right. As long as I've done that, that's good. Um, yeah. So unfortunately, the time is gone, and yeah, and I need to go. I haven't eaten yet. I need to go eat and spend some family time. I'm sorry.